Hello, I'm Cameron Bishop, and today we're going to be talking about acids and bases. So first off, what are acids and what are bases? Well, acids and bases are used to describe the chemical characteristics of many things that we use daily. There are many things in daily life that you wouldn't necessarily clarify as an acid. When someone thinks of an acid, they think of a something that would dissolve somebody's hand off or something like that. But there are actually many acids that us as people can consume and eat and use on a daily basis. So acids have many properties. Usually sour. When you taste them, they're sour. The electrolytes, they react with hydroxide ion containing compounds to produce water and salt. They also neutralize a base, which is the opposite of an acid. And they react with metal. That's one of the key things about acids, is they react with metal. Some examples of these include hydrochloric acids, which obviously, but oranges, grapes, milk, even lemons, limes, white bread. It's all types of things that we use on a daily basis that you wouldn't consider as an acid. Now to bases. Now what are bases? Well, they are actually more the opposite. They have more of a bitter taste. They do not react with metal. That's one of the main things when it comes to these types of clarifications, is that it's easy to choose between the two because it does not react with metal. They use a hydrogen ion to produce water and salt. And some examples of these are eggs, human saliva, strange, seawater, borax, and blood plasma. Okay, there you go. So, continued. To keep going, we'll get into the types, these different types. So there's 3 types. There's strong, weak, and non-electrolytes. Now, this is all depending on the ionization of each acid and or base. Okay, so a strong acid or base is when it ionizes completely. Weak is when it only ionizes to a small extent, not fully. And then obviously non-electrolytes is when they just do not ionize. I guess it'd be ionized at all. Yeah. Okay. Then you get into the pH scale. Now the pH scale is what you use to measure acids and bases. It's a number line. It goes from 0 to 14. 7 is the neutral. Okay, something that's neutral. It's neither a acid nor a base. It's right in the middle. Now bases are from your 7 to 14 range, and your acids are from your 0 to 7 range. Okay. Now, that's what many people use in school and in daily life to determine how acidic something is. The more acidic, the more dangerous it is to consume, the more, it's more dangerous in that effect. Now, if a substance is more acidic, then the hydronium is more active. So hydronium comes with the pH scale. The more acidic it is, the more the hydronium is active. So it's when the water the acid bonds with the water in the chemical reaction, is when the hydronium is produced. That's how we decide how much hydronium there is in a certain acid, and so on and so forth. So there are different types of theories when it comes to this stuff, and those will be the Arrhenius and the Bronsted-Lowry theory. Now, they tended to disagree a little bit. Now, the Arrhenius theory states that all acids contain H+, and all bases contain OH negative or -1. The Bronsted-Lowry theory is actually the opposite. So these state that acids are proton donors and proton acceptors. So bases don't require the HO or the OH minus. It actually is the opposite. So when it adds to it, it is the H3O plus. Okay, that's the difference between these two types of theories that they have debated about over time. Now, acids and bases, there isn't much to go into when it comes to them, mainly just determining what the difference is in the two types of characteristics, how they look, how they feel, how they taste, so on and so forth. But basically, the interesting thing that I found about all these acids and bases is that there are so many things in this world that would be clarified as either or that we end up using that you wouldn't really necessarily think of an acid or really basic, but it really is interesting how that distributes. So that's all I have for my presentation on acids and bases. There isn't too much to go into, but there you have it. Thank you.